Alrighty, so we are going to start our discussion for chapters 32 and 33 for our next exam. I'll be the chair and we will just go over a few things. I'll start by asking, does anyone have any questions or want to clarify any topics that they're confused about?
I can start. So
Awesome.
for me, I just want to clarify speed class. So is it basic? It says program sensitivity for the digital processor or reader to the signal from the image receptor. So is it just like how sensitive the machine is? It has nothing to do with like AVP or anything. It's the machine itself.
Yeah, I looked that up too because I was a little confused. It says, so how I interpreted it was it measures how efficient an imaging system converts X-ray exposure into visible images. So it's just like efficiency, it seems like.
Mhm.
And then a higher speed class means that the system requires less radiation to produce an image. So it's one of those inverse relationships, of course.
So a higher speed class is better for a patient dose.
Correct. That's yes. Also, there's the equation speed equals one divided by exposure required.
Mhm.
Is that is that chapter 22 or 32 or 33?
32.
32.
32. For speed class, it's speed equals one over exposure required.
Mhm.
Or I'm still kind of confused about the fog and the frequency processing. Do you guys know anything about how to break that down? I feel like it's like easy, but I just can't.
What chapter is it?
It's 33. I think we just went over it this week. It's like in his videos. I just can't.
Fog and reprocessing.
It's like fog pattern cleanup by frequency processing. Frequency processing has ability to clean up not only the general effects of scatter noise through the noise reduction algorithm, algorithms, um, but also it has a effect to clean up specific fog patterns. So it's like, is fog coming from the plate or like it's coming from something? Where is it coming from?
Fog, maybe the same thing as scatter. Is it related to scatter?
Hmm. Let's say here effects of scatter radiation on digital image. Effects. There's like something called pre-fogging where it occurs during a radiographic exposure and the effects of pre-fogging. That's scatter, I believe. But then after there's like another fog.
So I guess frequency processing has the ability to clean up not only the general effects of scatter noise through noise reduction algorithms, but also uh, remarkability to clean up specific fog patterns within the latent image.
Mm-hmm.
But you're asking where the fog comes from?
Yeah.
Okay.
Like it's just scatter. Like that's the only.
That's what I thought.
and then it shows up on the histogram.
Or is it like depending on the hertz?
I wonder if it's also environmental. Like, is it the light in their body and just like things that can make the image not look as good? So, like, if they're really, really big, maybe that might make the image look not so good. Or,
Yeah, because it's like over here, like on page 582, like it shows like the S minimum, S
Yeah.
max, and then it has like pre-fog and then added fog.
and then maybe like artifacts in there too. Like, if they have some sort of like hip replacement, maybe that'll throw off the image too and cause fog.
Yeah.
So like maybe there's different types of fog, like artifact fog, and then I don't know the depth of like how much we need to know about fog and
Mhm.
all the little
That's not
categories.
what I'm understanding. It's like it's scatter and then the frequency processing cleans it up. But then how would we fix it if we have fog? I don't know. I'm just going a little spiral, I guess.
Oh, that's fair. Because like if they're really big and then they have a hip replacement and the picture's foggy, like how do we like that's not really things that
When
we
you up your
fix.
KV and your mass, and then what? But then you can't. I don't
Then
know.
you don't want to mess too much with it.
Because then there's more scatter if there's a bigger patient, and then
Yeah. So that's a good question.
Yeah, because then on 584, it talks about like the hertz bar patterns regarding fog.
mm-hmm.
So yeah, that's a little confusing because it talks about like the frequency of each hertz
Mm-hmm.
and how it's related to its fog. Yeah, that's a little confusing.
So when Steele sent out the announcement about the three questions that we can focus on, just making sure we can answer those questions. One of them was, what are the corresponding factors in digital imaging? And then goes example, rescaling is related to blank, alignment is related to blank, and etc. So the four I drop down would be rescaling, windowing, edge enhancement, and alignment. Do you think that there's
Is that in chapter 32? Or
yeah.
like the previous chapter, I feel like.
Well, I feel like it was the previous chapter, but then he listed this question out,
That's like one of the
and I
yeah.
felt like that was kind of yeah, from the previous chapter, right?
Mm-hmm. But
But
then in chapter 32, I think it says using alternative processing algorithms. I'm just trying to skim through these remixers. Mm. Yeah, because it's in here, there's also windowing.
so then the answer to those, at least those two questions, rescaling is related to brightness adjustments and leveling. Do you think that's the correct answer?
Yeah, he has like in the PowerPoint, in the second one of 32, he has like a little chart,
Uh-huh.
a little, oh, it's blurry, but there's a little chart that goes over like
Oh, okay, cool.
quality and the digitized radiography, and it says rescaling has to do with brightness and density.
Oh yeah, that's right. There's like that chart.
Mhm.
And
It's on page like 561 too, I think. Right? Is it that one where it's comparison of primary controlling factors? Is that the one? Like image
So
quality.
Yeah.
table 32.5.
Mm-hmm.
Yeah. Yeah, I remember he said like to try to like understand that chart.
Yeah.
Yes. Image call.
I guess that also relates to the second one too. It's like what factors are actually responsible for image quality in relation to CR and DR. It'd be those.
Mm-hmm.
Is that the brightness, density, grayscale, sharpness, magnification,
Yeah, that one.
and
Mhm.
shape distortion?
Yeah. One, two, three, four, five, yeah. And then what's the other one? Says what percentage of exposure deviation requires action on the part of the tech? What percentage of exposure deviation? Would that be like the 15% rule thing?
What was the question again?
It's on his power points of interest. It's like what percentage of the exposure deviation requires an action on the part of the tech? A part of the tech.
Is that regarding the deviation index? Or is that something different?
No, I think it's correlated with that.
What page is that? The deviation.
I think it's like chapter 32, like 544. I think it like briefly talks about deviation index. And then it,
Oh yeah, the standardized deviation readout along with indicator actual exposure area term. Um,
it says that can be used by all manufacturers regardless of their specific methods of calculating the EI. But I don't know if that's related to what you said.
The recommended DI should be prominently displayed to the operator digital radiography system immediately after exposure, which
Mhm.
is what we see. And then on the second page says there's three broad approaches to constructing the scale of an exposure indicator. Would that be part of that? It's like
I
logarithmic.
assume so.
I think this one, also another chart that he has in his PowerPoint. It's table 32-4. And then it just shows like, um,
Oh, I see, I see.
yeah, like the less than 50% that's low underexposure, that one would need a repeat because there's excessive model.
Mhm. Yeah, it says like under 3 point something exposure deviation, 100% high, no repeat unless you burn out overexposure. But this is just based off like I guess in general, right? It's not like specific to like a Fuji or Philips.
Mm-mm. Yeah, I think it's just general. So if it's over the deviation index of 3, +3 or -3, that's when you would need a repeat, right?
I think you would repeat if it's underexposed.
Yeah, it's only from.
No, you need to take another exposure if it's
Right.
overexposed as well. But yeah, that's correct. Greater than 3 or less than 3, then it will require a retake.
Over 3?
Yeah, because you're burning out the image too much. Like you start.
Oh, yes. It says repeat only if burnout occurs.
Mhm.
And then saturation is like where it's like completely where you can't see any of it, correct? Where it's like, there's an example in here.
Is it when it's like super bright?
It's super bright and like super dark too, because you could burn out. It says no repeat unless image burnout occurs from saturation. So if you burn out, you could still use it, but if it's completely saturated, which I'm assuming like there's no like range of like grayscale that it
Mm.
means it's straight up saturated.
When you start losing the contrast.
Yeah.
That makes sense. I feel like a burnt out image is like when it's kind of white too.
Mm-hmm. Yeah, it says do not mistake a very dark image for a saturated image. If any details at all can be made out of a dark portion of the image, it's overprocessed but not saturated. True saturation presents a flat black area with absolutely no detail present.
The image is underexposed. It should not be repeated unless the radiologist finds the level of noise in the image unacceptable.
Mm-hmm. It happened to me in clinical. It was like an underexposed shoulder with a portable, but the doctor came in and was like, I'm gonna clear it. I'm not gonna have you guys repeat it because you could obviously see the shoulder like being dislocated.
Mhm.
On the book, I think it was like chapter 32, because I didn't see it on his slides. Do we need to know like the counting average or like the is it the arithmetic average? Like that whole MDN equals n plus 1 divided by 2 count up. I don't know if you guys read
Oh,
that.
it's on page 54 or 544.
Yeah.
I think it's 54. Um,
44?
5
544.
544. I think it's like about pixel values.
Yeah, it says n
But
number
like
of
I didn't
pixels.
see it on his slide, so it's like I was confused about that.
Yeah, because he does have us read the exposure indicators.
Mm-hmm.
Do you guys understand windowing?
Kind of. Trying to figure
I was
out.
having a hard time figuring out exactly what that is.
Sorry, I'm just trying to read over the MDN thing.
Yeah, I was confused.
Maybe we could ask him.
Yeah, I'm hoping like after this video he can answer our question, but I just kind of wanted it like explained between counting average and I can't even say it, arithmetic average, because it's regarding the pixel values, but
If we're gonna need to know this formula to solve something.
yeah. Because then when it says count up, like I don't know what that means.
Mhm.
Yeah, but I mean, if nobody else gets it, we can just wait for him to kind of explain that.
Yeah, I'm not sure about that one either.
So,
Um, Dustin, you know how like you pull up your camera and like you want to adjust the brightness like up and down? You want to take a picture?
Yes.
Like when you boot, that's how I think about windowing. I'm like trying to think of it as a way like when you try to take a picture and like you click on it and you like arrange it to like really bright and really low. That's how kind of like how windowing would work, but it's like at a certain scale.
You know how after we take an image, Justin, the guys will swipe your mouse up and down and side to side?
So they're like trying to clean it up.
Yeah, like you remember how they like swipe the mouse up and down to play with the image and like to make it look prettier?
Yeah.
Okay, that's what window width and window level is. So like window width is when like you're moving, I think the mouse side to side and it determines the contrast. So it either, like will make it more black and more white. And then window level is when they're swiping up and down, and window level is determining the brightness to make it brighter or darker.
Sure.
But then that's why steels like don't really mess with your image before you send it out, because it impacts the original data and it's not good to send out an image that's been edited. That's why you should just send out the original image and then the radiologist can go from there rather than like making it pretty before you send it out, because it loses data when you edit your image on our monitors.
it messes with the S value, doesn't it? Yeah. Okay.
Yeah, you can't- the computer algorithm will
Mhm.
mess with the S number.
Because like majority of the text do anyways, but I was like, wait, that doesn't it affect the S number?
Do you guys have any other questions?
I think so.
Not really. I'm just hoping after this video he can kind of go back and answer what we're all confused about.
Yeah.
Yeah, there's a lot in this chapter.
Hmm.
Yeah, some new stuff. Um, well, that was a good review. I feel like we went over speed class and windowing and fog. Um, and then we are left confused about what was the one topic?
And
It was the between the counting average and the arithmetic average.
Yeah. Okay, so we need clarification on that.
Yeah, just to explain it.
Okay, cool. So that's kind of a rundown of what we went over today. And we don't have any more questions. So cool. I'll end the meeting here then.